Okay, for number 16, the apparatus shown is used to measure the rate of reaction. Okay, and as you can see here, this is a gas syringe, and we have here reactant. Okay, which equation represents a reaction where the rate can be measured using this apparatus? So the equation here must have releasing the gas, so it will be collected over here. So as you can see here, only the A, it has the hydrogen, it releases the hydrogen gas, while the others, the B, C and D, there is no sign of a gas. Okay, so number 16 is A. Okay, now let us move to the next one, number 17. Okay, P is a hydrated metal salt with a blue color. When P is heated, water is given off, leaving a solid Q. So it's P2Q. R is a hydrated metal salt with a pink color. When R is heated, water is given off, leaving a solid S. So R heated to become S. Okay, now they're asking for the name of P and the color of S. Okay, now as you can see here, this experiment is regarding a presence of water. So for presence of water, there is a two chemical. So number one is a copper. Okay, another one is a cobalt chloride. Okay, so cobalt chloride. So anything to do with copper, you will change from white to blue when in the presence of water. However, cobalt chloride, you will change from blue to pink color. Okay, so as you can see here, when the P is hydrated metal salt, it is in a blue color. So which means the P is the copper. And as you can see here, that when the R is hydrated here means they have water. Okay, water molecules. So it's with the pink color. So pink color, it means the S is cobalt. Okay, so when the cobalt is in a dry without the presence of water, it is in a blue color. Alright, so here the answer here will be C. Name of P is a copper sulfate. It can be a copper chloride. Okay, also now for color of S, they are asking S, this one. Okay, so from pink color, it will reverse back to the blue color. Okay, so this is for the number 17. Okay, now let us look at number 18. Okay, magnesium react with copper to oxide to give magnesium oxide and also copper. So it's magnesium plus with copper oxide. Magnesium is much more reactive than copper, so it will displace the copper and form a magnesium oxide. So this is we call as a displacement reaction. So which substance is the oxidizing agent? So as you can see, let me write it down here, all the oxidation number. Magnesium is 0. Magnesium here will be plus 2. I mean as a magnesium 2 plus. And copper here will be 0 and copper here will be 2 plus. So magnesium will be oxidized. Alright, this is the oxidation process. But the one helping magnesium to get oxidized is this. So these are the oxidation agent. So oxidation agent is a copper to oxide. So your answer here is B for number 18. Okay, now we go for number 19. Okay, for number 19, part of the periodic table is shown which element forms acidic oxide. Okay, this one is interesting because every year they'll be asking this type of question. Okay, So here, okay, so this is a group 1 and 2. So the oxides of group 1 and 2, it will form alkaline or base. Okay, alkaline or base. Okay, like a group 13 here, aluminium, this is boron. The aluminium should be here, and this aluminium, they have a characteristics of amphoteric characteristics. Aluminium oxides have amphoteric characteristics. Okay, what is amphoteric? Amphoteric here means they can behave as a base or as an acid. Okay, so they behave as a both. So this is a group 14, 15, 16 and 17. So all these four groups, they are oxides. Okay, is an acidic oxide. They have an acidic oxide. So they are asking for acidic oxide, right? So the best answer here will be B. Okay guys, so I hope you can understand this. Okay, okay, now for number 20. When aqueous sodium hydroxide is added to a solution of a metal ion, a gray-green precipitate forms, which dissolve in excess to form a dark green solution. Okay, what is the identity of the metal ion? So as you can see here, the metal ion that forms a green precipitate is only two metals, which is iron 2 plus, and we have a chromium. Okay, chromium 3 plus. So both of them will form a green precipitate, but they have mentioned here is dissolve in excess to form a dark green, is dissolves. Okay, but iron will form a precipitate. Okay, they'll form a precipitate in the excess of sodium hydroxide. However, your chromium here, it will dissolve in sodium hydroxide to form dark green solution. Okay, this one will dissolve. Okay, but if you look at another test, this is for the sodium hydroxide. The another test will be the ammonia. So both will be as a precipitate. So please remember this, the comparison. So your answer here is A. Okay, so this is an extra knowledge for you. Okay, now look at number 21. Which statement about strong acid are correct? Okay, number 1. They have a high concentration of OH. No, acid only releases hydrogen. The presence of hydrogen makes them as acid. Okay, so 1 is wrong. Okay, now look at number 2. They have a pH value of 1. They have a pH value of 1. Yes, it's a strong acid. Okay, they completely ionized. It's not partially in water. Yes, they turn the litmus paper red to blue. For acid, it's supposed to be blue to red. This is acid, and this is alkaline. So your best answer here will be C, 2 and 3. Okay, now let us look at number 22. Okay, 22, metal X reacts with a non-metal Y. Metal and non-metal, they'll form an ionic compound with a formula of a X2 and Y, which means Y will be a positive 1 and X will be a positive 1 and Y here will be a 2 negative. Okay, so X in a group 1, yes, this one should be a group 1, and will be in a group 1 and here will be in a group 16. So 1 is selected. Okay, number 2, X is in group 2, so it's just not correct. So 2 we cancel it out, and Y should be in a group 6 or 16. Yes, so it's 1 and 3. Okay, so this one is the for number 22. Okay, now let us look at next one. Okay, for number 23, the table gives some properties of a group 4 elements. This is a carbon, silicon, germanium, tin and lead. Okay, so which row describes the properties of silicon? So here, if you look at the boiling point, going down the group, is the boiling point is decreasing. So here should be roughly about 3000 something. Okay, 3000 something. And if you look at the density is getting bigger. So here should be roughly about 3 to 4. Okay, 3 to 4 grams centimeter cube. So if you look at here, the most suitable answer, if you look at, okay, now let us check the boiling point. This is not suitable. This one most probably, this is not, and this is not. So B and D is out. So if you look at both of these, A and C, the answers here is, we cannot choose C because it's very big, okay, compared to slot in between this. So your best answer here will be A. Okay, and then the reason why the boiling point for group 14 is going down, is it decreasing? Why is it? Because when you're going down the group 14, the atoms gets bigger and bigger and bigger and bigger. So the electrons loses the, so you can say the electron having a less attraction force from the nucleus. Okay, so when the forces is getting lesser and lesser and lesser, so we need a lesser energy to make them from liquid to the gas. Okay, so this is the boiling point. However, for the density, when you're going down the group, it's getting bigger and bigger and bigger. So what happens is, density is mass over volume. When at a constant volume, the masses is increasing because of the increasing proton number and also electron number. Okay. Now let us look at number 24. Okay, the metal beryllium does not react with cold water. It reacts with the hydrochloric acid but cannot be extracted from its ore by using carbon. And where is the beryllium placed in the reactivity series? It's a beryllium. Okay, so this is the arrangement. Okay, so these are the arrangement of this electrochemical series. And if you look at here, it reacts. So this is one of the clue here. Okay, cannot be extracted from its ore by using carbon. So it means beryllium is much more reactive than carbon. Okay, and if you remember the position of carbon, the carbon will be over here above the zinc, because iron can be extracted with the carbon, using carbon. So the beryllium should be at A. Okay, so okay, now let us move to 25. Okay, why is cryolite is used in the extraction of aluminium from bauxite? Okay, cryolite, they have two main purpose over here. One is to lower down their melting point of aluminium oxide, because aluminium oxide, their initial its melting point is about 2000 degrees Celsius. After the addition of a cryolite, it will reduce to 900 degrees Celsius. And another one, it also acts as a solvent. Okay, solvent for the aluminium oxides. So let us check one by one. They do not behave as a catalyst, so it's wrong. As a solvent for aluminium oxide, yes, just as I've explained to you. Okay, C, it stops the carbon and not burning away, not really. It reduces aluminium ion in aluminium oxide. Nope. So your best answer here will be by. Okay. For number 26, which statement about the use of metals are correct? So iron is used to make aircraft because iron has a low density. So this is a wrong fact. They will be using a duralium to make an aircraft because it has a it's a hard and also it has a low density. So number one is a no. Okay, number two, copper is used to make electric cables because copper is a good conductor of electricity. Yes. Aluminium is used to make brass because aluminium is strong and hard. So to make the brass, we need a copper and also zinc. Okay, and it's not aluminium. Okay, number four, iron is mixed with an additive to make an alloy used in a chemical plant. Yes, it is. Okay, so it's 2 and 4. D. Okay, number 27. Okay, which row describes the reaction of a magnesium hydroxide and also magnesium oxide? Okay, effect of heat on a hydroxide and effect of heating oxide with carbon. Okay, if you notice here, heating the oxide, magnesium is much more reactive compared to carbon. Carbon is below, so there will be no reaction. Okay, there will be no reaction because magnesium is already more reactive than carbon. Yeah, supposed to be either B or D. Okay, effect of heat on a hydroxide. So they will form a magnesium oxide due to thermal decomposition. So when it's being heated, thermal decomposition, so they will be having magnesium oxide plus with water. So your answer here will be B. Okay, now let us look at number 28. The property of an element is listed. Okay, melting point is 3000 something degrees Celsius. Some of its compounds are catalysts. It has variable oxidation state. So this one should be, this one itself, it shows it is from a transition elements. D. Okay, for number 29, petrol burns in a car engine to produce waste gas which leaves through the car exhaust. One of these waste gas is oxides of nitrogen. Okay, which statement describes how this oxide of nitrogen is formed? Okay, so for your information, nitrogen is there in the air. Okay, is the largest percentage in air, and oxygen is about 21%. So nitrogen is everywhere, is inside the air. So the engine, okay, if you look at this engine, we have this spark plug. So the spark plug, between the spark plug and the space over here, it will transmit a high voltage, a very high voltage, which is a trigger to combine nitrogen and also oxygen chemically. So they will be combined over here to form the oxides of nitrogen. Okay, so it happens inside the engine. So nitrogen reacts with the oxygen in the car engine. So this is the answer. Please remember this. It could come out in a 2020 and also 2019. Okay. Okay, for number 30, which combination of chemical compound can be used to produce the fertilizer shown? So now we have nitrogen, phosphorus, and also potassium. So these are the ratios of it. So nitrogen, phosphorus, and also potassium. So they have a 21, 16, and also 8. So what we will do over here, we will divide by its relative mass. So which is 14 for nitrogen, 32 for phosphorus, and for potassium is 19. So once we divide, we will be getting here 1.5, and here will be 0.5, and here will be, so it's 8 divided with 19, you will be getting here about 0.42. Okay, now we have to take the smallest number and divide it with all the moles. So 0.42 and divided by 42 by itself. So here will be getting 1, and 0.5 divided with 0.42, we will be getting here about 1.2, and here will be 1.5 divided with 0.42, and we will be getting here about 3.5. Okay, so we can make it as 3, 1, 1, the simplest form. So now let us search for nitrogen 3. So it means in this compound they have 3 nitrogen, phosphorus 1, and potassium is also 1. So okay, now we look at the answer. Okay, so the B, they have calcium, so cannot. And the C, they do not have potassium, and phosphorus, no. And for D, if you look at it, there is no such thing as for phosphorus and potassium. Potassium they do have, but phosphorus no. So it's A, because they have a nitrogen, they have a phosphorus, and they also have a potassium. So other than this, we can also use this calculation method. Okay, for number 31. Okay, for number 31, which process does not produce carbon dioxide? So does not produced carbon dioxide. So respiration, they do produce. Reaction with acid and metal, yes, they do produce salt plus with carbon dioxide and water. They do produce carbon dioxide. Combustion of hydrocarbon, every combustion will end up, if it is a complete combustion, it will end up in carbon dioxide and water. So photosynthesis is the only one will absorb, will use carbon dioxide to synthesize the food, glucose. So 31 is pi. Okay, now we look at 32. Which substance is used as a bleach to manufacture paper? So please remember this one, guys. As a bleach, they will use sulfur dioxide. So this question is being repeated in 2017. Okay, I'm not sure it's a May, June or October, November, but there is one question over here. So it is a sulfur dioxide as a bleach. Okay, now we go to 33. Okay, what is the industrial use for calcium carbonate? Calcium carbonate. So, so here will be, so for cracking of hydrocarbon, we do not need calcium carbonate. So C is your answer. Manufacturing of cement. It's because cement, this one will be used to produce slag. Okay, slag in the process of producing iron from hematite. Okay, okay, this one is because the hematite here, okay, it contains ferrum oxide, okay, and also it contains impurities, which is a silicon dioxide. So as a raw material for this process, they will use calcium carbonate, where this calcium carbonate will be thermally decomposed into calcium oxide. So this calcium oxide will combine with the impurities and it will form calcium silicate. This is a calcium silicate. So calcium silicate is used, calcium silicate, okay, calcium silicate is used as one of the raw material for the manufacturing of the cement. Okay, so 33 is C. Okay, for number 34, propane reacts with chlorine. Propane, so this is an alkane, not alkene. Okay, so if it is an alkane reaction, it must be under ultraviolet, and this process is called as a substitution. So how do they react? So let me just write it down over here. We have 3 C's. Okay, so each of these is a hydrogen. Okay, so I don't just let me give me a minute. Okay, hydrogen, okay, and then the combined with the chlorine. So this reaction is only with the presence of the UV light. Okay, so now what happens? Okay, let me expand this chlorine, the chlorine part. So we have this. Okay, now one of them will be substituted with this chlorine. So this chlorine will be substituted here, and the hydrogen will come out and combine with this one. So your end product here will be one of the particles here will be chlorine, the rest will be as a hydrogen, and you will have another product for this, which is a hydrogen chloride. So this is a substitution reactions. D is your answer for number 34. Okay, let us look at number 35. Okay, the pie chart represents a composition of a natural gas. Natural gas, okay, which sector represents methane? Okay, please remember that methane will be having a largest portion of this natural gas. So your answer will be a D here. Okay, it's the largest portion. Okay, for number 36. Which statement describes the reaction between ethene and steam? Okay, this is for the production of alcohol, ethanol. So which means you will have this H, and as there is a double bond, so it is unsaturated. Okay, so they'll mix with the steam. So the steam can be separated as a HOH, and the double bond will break and they will form ethanol. So this is the ethanol. So over here, So let us go through one by one. It's a cracking reaction. No. It's an oxidation reaction. No. Slow reaction producing ethanol and carbon dioxide. This one must be fertilization. Okay, it's sorry, not fertilization. It's a fermentation process. Okay, fermentation process. Okay, then if you look at here, anything to do with the alkane. Okay, anything to do with the alkane, it must be addition reaction because they are adding it. Okay, they are adding it. So it should be by here, 36. Okay, now let us go for the 37. Okay, for 37, the formula of hydrocarbon is CX and HY. The equation for its complete combustion is shown. Okay, so here we have 5 carbon. Okay, if you have a 5 carbon here, your X here will be 5. If it's a 5, now we have to look for the hydrogen. Hydrogen is here. Okay, so there's a total of 12. So hydrogen here will be 12. Okay, so it will be B with 5 and 12 over here. This is for number 37. Okay, now let us look at number 38. Okay, 38, the formula of an ester is this. Ester. Okay, ester is a combination of a carboxylic acid and also alcohol. Okay, let me make it smaller so I can have a more explanation to you. So if you look at here, 1, 2, 3 and 4. So we have a borderline here, so there is a 4 here. 4, so which means you got 4 H 1, 2, 3, so 3 H7 and COOH. Okay, this is from here, and the other side, this one, it is coming from alcohol, so it's a C123 H7 and OH. Okay, so when they are forming ester, the hydrogen from an acid and the OH from the alcohol will combine to form the water. So this is acid is butanoic. Okay, butanoic. So total carbon here is 4. This one is a butanoic, so it's either A or B. And look at alcohol. Alcohol will be they have a 3 carbon, so it should be propanol. So 38 here should be by. Okay, so this is your answer. Okay, now let us go for 39. Okay, 39. The molecule 1 undergoes a process to make molecule 2. Okay, this is to make. Okay, describe which row describes the molecules and the process. So molecule 1, process, and molecule 2. So here we will have, okay, let us look at one by one. There is a monomer. If monomer, it must form polymer, and it is a polymerization. So cracking is wrong. B will be considered. Okay, small molecule to monomer. Does it make sense? Small molecule cracking to form monomer. Does it make sense? So the answer is A. Monomer will form polymer with the process of a polymerization. Okay, so this is for question number 39. Okay, now let us look at the last one. Okay, number 40. Which structure represents a protein? Okay, for your information, protein has a, okay, protein is a polymer which its monomer is amino acid. Okay, so I just write it down here. Monomer is amino acid Okay, this amino acid, it contains amide group, okay, amide group, and also carboxylic group. So these are the two groups that they have. Okay, now example, let me just show to you. Okay, this one we have a nitrogen. I just show to you one side. Yeah. Okay, now there is another one more side for carboxylic acid. So this is double O and OH. Okay, so now what happens here is double bond O and OH. Okay, so over here the OH from a hydroxide, carboxylic acid, and the hydrogen from an amide group, okay, will be combined to form the water, and their combination will produce and here we have C double bond O. Okay, so this one we call it as an amide linkage. Okay, it's an amide linkage, or sometimes we call it as a peptide linkage. So this is an amide linkage. So this is the link, amide link. Okay, now we have to choose the suitable one. So it's not a B, it's not a C, so it's either a A or D. So the best combination over here will be, so the A and D, the difference here is the D having the same, okay, D is having the same linkage. And look at this side. So let us mention, okay, let me mention that each of these, if it's an amino acid, they contains both, okay, they contain both amide and also carboxylic acid. So which means that this side here will be the acid part, and here will be the amide group. Okay, so the most suitable answer here will be the A. So let's say we just make it as R1, R2 and also R3. So each of them will be having the opposite side. So which means this is the amino acid. Okay, so this is for the question number 40. Okay guys, so all the best for your revision. Please like and subscribe, and all the best for your revision. Thank you very much.